Hey guys, so today we're going to go over some vocabulary that you're going to need to know for the upcoming unit on polynomials. So we're going to break down what a polynomial is and just the different features of polynomials that you're going to be expected to know. So let's get started. First thing that you need to know is what a term is. So that you're going to hear a lot in Algebra 1. So a term can either be numbers, variables, or numbers times variables. So this is an example of a number times a variable with an exponent. Let's break down what each of these are. So this x, you've seen these before. This is called a variable. It's a letter that represents an unknown number. So we do not know what x is. That's why we call it x. Then we've seen numbers in front of variables before. Those are called coefficients. It's number being multiplied to the variable, usually written in front of it. So this is saying 7 times x to the third power. 7 is our coefficient. And please keep in mind that 7 is the coefficient, not 7x or 7x to the third, just the 7 is the coefficient. Then we have this 3 here, and that's called an exponent. So this is saying how many times, a number saying how many times that number or term is multiplied to itself. So this is saying x to the third power, which would mean x times x times x. But instead of writing that out, we use that 3. So hopefully these are all things that you've seen before, especially an exponent. And let's keep moving forward. So sometimes x is going to be written by itself, okay? So when there is no coefficient, so no number in front, and there's no exponent, no little number at the top, that means both of those numbers are 1. So if there's no coefficient, the invisible coefficient is 1. If there is no exponent, the invisible exponent is 1. So this is the same as this. There's technically an invisible 1 in front, and then there's a little invisible 1 as an exponent. An expression. An expression is one or more terms that may include variables, constants, operators, and grouping symbols, such as addition, subtraction, multiplication, or division. So that means there is no equal sign here. This is an example, 3x squared plus 5x minus 6. So we have 3 different terms. They're grouped together by different grouping symbols, such as addition and subtraction, and there is no equal sign. Okay, so now we're going to talk about the different kinds of polynomials based on the amount of terms in each expression. So you're going to see what I'm talking about. So the first one we're going to talk about is called a monomial, which we're going to look more into tomorrow and on Friday. So that is a single algebraic term, so only one algebraic term. For example, this is a monomial. This is considered one term. You can see there's no addition, no subtraction, so it's one term. Next, we have a binomial. It is an expression with 2 unlike algebraic terms. We'll get more into what like terms are, but today we just are going to stick to what unlike terms are. So this is an example, 3p plus 18. These are 2 different terms. That's why they're in 2 different colors, and they're grouped together with an addition symbol. We cannot add these together because this doesn't have a p, so this is as simple as it can get. A trinomial, and you can see they're kind of like prefixes here. So bi means 2, tri means 3. So this is an expression with 3 unlike algebraic terms. Here is an example. 16x squared plus 5x minus 11. 3 different terms, so it's 3 different colors, and they're grouped together by an addition symbol and a subtraction symbol. And lastly, we have a polynomial. So the prefix poly means many. It's an expression with 1 or more unlike algebraic terms. So here's an example. 14y to the 5th plus 3y to the 4th minus 10y to the 3rd plus 5y to the 2nd. So here we have 1, 2, 3, 4 different terms. But remember, a polynomial can mean many. So we can have 4 terms, 5 terms, 10 terms. But then we can also have 1 term. So these are all considered polynomials, but it can just keep going on. All right, next let's talk about what standard form is. You're going to see that a lot in the upcoming unit. We really need to know what standard form is. So standard form is when a polynomial is written with the exponents in order from largest to smallest. So descending order. So here is an example. We have our polynomial, and if you look at our exponents, our little numbers written next to the x, they go in order. So we're not looking at the numbers in front, we're not looking at the signs, we're only looking at the exponents. So 4, 3, 2, there's that invisible one that we spoke about before, and then this doesn't even have a variable, so that's going to go last. This is standard form. It needs to be written with exponents from largest to smallest. So here's an example. Write the following polynomial in standard form. We have negative 3x to the 6th minus 9x minus 10x to the 7th minus 17 plus x. I want you to take a minute, and I want you to write this in standard form. Remember, it's when the exponents are written from largest to smallest. You should be looking at the polynomial and finding the largest exponent and working your way down. And here is the answer. Negative 10x to the 7th power minus 3x to the 6th plus x squared minus 9x minus 17. So you can see our exponents go from 7, 6, 2, 1, and no variable. Our exponents are from largest to smallest, so it is in standard form. Now we're going to talk about different features and characteristics of polynomials once it is written in standard form. So the first thing is leading coefficient. This is the number leading a polynomial once it's in standard form. So that kind of gives it away. It's pretty obvious what leading is. If you're a line leader, you're in the front. So it's the same thing. It's kind of like the line leader of the polynomial. But it has to be written in standard form first. That is very, very important. If it is not written in standard form, you're not going to have the correct leading coefficient. The next definition is constant. So a constant is a number without a variable. So just the number by itself. Could be positive, could be negative, could be a decimal, could be a fraction, as long as it does not have a variable. So it does not have a letter next to it. And lastly, here we're talking about the degree of a polynomial. So that is the highest exponent of the expression. So whatever the largest exponent, that little number at the top of that variable, whatever that largest exponent is, that's considered the degree. So here's an example. We have a polynomial here, and it is written in standard form. We know that because the exponents go from largest to smallest. So 5 to indivisible 1, no variable. So this 3, that's the number leading our polynomial written in standard form. That is our leading coefficient. Next, we have this little 5 here. That is the largest exponent. That's our degree. And lastly, we have this little number on the end. It does not have a variable next to it. As you can see, these all have variables next to them. So that is considered our constant. So we classified polynomials based on how many terms there were. Now we're going to classify polynomials based on the degree. So it's considered linear when the highest exponent in the whole polynomial is 1. And we'll take a look at some examples. When the highest exponent is 2, that's when it's quadratic. When the highest exponent is 3, that's when we call it cubic, so cubed. Next, when the highest exponent is 4, we call that quartic. And when the highest exponent is 5, we call that quintic. There are many more after this, but we're going to stop here. Let's look at some examples. So we have a polynomial here. And let's see, the highest exponent is 3. So the degree here is 3. Now, because the highest exponent is 3, it is considered a cubic polynomial, just like we looked at in the last slide. Example number 2. The highest exponent here is 5. So that means the degree is 5. And we consider that a quintic polynomial. Let's take a look at example number 3. We don't see any exponents here, but we know that there is that invisible 1 right there. So the highest exponent here is 1. So we call this linear. Example number 4. Our highest exponent here is 2. So the degree is 2. And we call this quadratic. Now this last example, our highest exponent here is 4. So the degree is 4, and we call this a quartic polynomial. Now you can tell we did not count how many terms, we didn't look at the numbers in front. The only thing that we focused on for the degree and the type of polynomial is the highest exponent. Now let's just do a quick check of all the different vocab that we've learned. I know that it's been kind of a lot of vocabulary, but as long as you know these key terms, it's going to make your life a lot easier moving through algebra, geometry, algebra 2, and even calculus. So let's go over this. State the following features of the polynomial below after it is written in standard form. So we have negative 5x to the third minus 18 plus 10x to the fourth. So the first thing we want to do is put it in standard form. That's written all in caps because that should always be your first step. Always get the polynomial in standard form first before you start answering any questions based on that polynomial. So remember, standard form is when the exponents go from largest to smallest. So let's look at our exponents here. We have a 3. This doesn't even have a variable. And then we have a 4. So this term is going to go first. This term is going to go second, and this is going to go last. 10x to the fourth minus 5x to the third minus 18. Now the leading coefficient, remember, it's that line leader, that number in front once it's written in standard form. So in this case, the answer is 10. It's that number right in front. Now a constant. A constant is a number without a variable. So which of our terms is just a number without a variable? This has a variable, this has a variable, this doesn't. That's our constant. Now, I know it says minus 18. I want you to treat that like a negative 18 in this case. So our constant is negative 18. Now let's find the degree. If you remember the definition of degree, it is the highest exponent in our polynomial. So that's usually, if it's already written in standard form, that's going to be the exponent in the first term, which in this case is 4. Now the classification based on the terms. So that means we want to count how many terms are in our polynomial. So remember, addition and subtraction is what separates these terms. So we can see we have one term here, one term here, and one term here. So this is 1, 2, 3. A polynomial with 3 terms is called a trinomial. So this is a trinomial. And last but not least, we're going to classify this based on the degree. So if our degree is 4, if you recall, if the highest exponent is 4, we call that a quartic polynomial. Okay, so you can keep referring back to this video for these definitions and this PowerPoint, but it's very important that you understand what all of these words mean.